Hey, hello, everybody.
Howdy.
We are excited that you are all joining us today. Today I'm really excited about this webinar. We're going to be talking about leveraging sensors for condition-based maintenance.
Oh, that's
Next
me.
slide.
Hold on, I got this thing all jacked up over here. Oh, what the heck? Okay, there we go.
Okay, so we always go through this every webinar, but for those of you that have never joined in one of our webinars before, we're going to go over a few ways that you can participate with us during this webinar. So we do have down at the bottom right corner on your screen, you might see a little question mark with a circle around it, and it says questions. If you have any really important questions that you want to make sure we see and address, that's the best place to post those questions. We also have the chat feature, which is on the bottom right. You'll see a little message symbol that says chat underneath it. So throughout the webinar, we'll probably ask a couple questions, and we'll be looking in the chat for your responses. So go ahead and type any kind of responses in the chat feature. So right now, we're going to do what we normally do, and we're going to test out the chat. So all of you that are here so far, let us know your name and then where you're joining us from in the chat. And as an added bonus, if you want to, you can add like what the weather is like right now. Because I'm in Eugene, Oregon, and it snowed. So we have about like 3 inches of snow, which is a lot for the valley that I live in. Brian, what about you?
We had about 4 inches of snow yesterday, but then it poured down rain today, and now it's like basically gone.
And you're in Baltimore, right? Or near
Yep.
Baltimore. All right, James is in Texas, and he
Oh,
says it is cold.
my man Cody's in here. See that? Who else we got? Got California, rain, cold rain, just all kinds of cold and rain.
Chicago, tropical weather. What does that mean? Tropical?
Yeah, what does that mean? 13 inches of snow, dang.
Wait, where's that at?
Just going too fast. Palo Alto, Florida, 80 degrees.
Whoa, Florida, 80 degrees. I'm in the wrong.
Egypt, Ahmed, dang. Wisconsin, 7.5 inches of snow.
I think all of us need to just go to Florida right now is basically what I'm seeing.
DC, I know that one.
John, where are you at? What's the weather like there?
I'm in North Carolina, and it's currently in the 50s right now. Actually, 60s. It's nice.
Calgary, minus 12. GW, I don't envy you.
Only 3 inches of snow in Kansas City. Yeah, that's about where we're at here, where I live. Okay, well, it looks like you all know how to use the chat now. This is really cool that we get to see all people from all over the United States, plus in other countries. We love that. So I'm here. Let's introduce the speakers, which I am one of them. And then we have my colleagues, Brian and John. Brian, why don't you introduce yourself and tell us a little bit about your experience?
Sure. So I'm Brian. I'm the head of community partnerships at Upkeep. I have been a heavy equipment mechanic, a maintenance manager, director of maintenance and reliability, and head of maintenance for several companies. And I was in the military as a GSE flight deck troubleshooter. Enough about me. Go ahead, John.
Yeah. Hey, everyone. My name is John. I'm a solutions engineer with Upkeep. Been with Upkeep for about 3.5 years now. Been doing maintenance asset management in the software space for 10 years. Happy to be here.
Thanks, John. And like I said, I'm Amissa, so I'm the senior marketing manager here at Upkeep. And as far as my experience goes that has to do with maintenance, back in the day, one of my first real jobs was working as a manufacturing technician in a semiconductor plant. And so I was one of the operators that operated the machines and equipment. So I personally never worked in maintenance, but I do remember when our machines would go down, and it was like a big deal when we had to call maintenance for downtime on our equipment. Also, 2023, I got my CMRP, which is Certified Maintenance and Reliability Professional Certification. So those is my relevant experience. Now let's talk about the webinar today. So for our agenda, first we're going to go into an introduction and overview of what condition-based maintenance is. Then we're going to talk about using sensors for condition-based maintenance. and then the benefits of that. And then John is going to show us what that actually looks like in a CMMS. And then we'll talk about some customer examples, and then we'll get into some Q&A. And I will have one thing, you guys hang in till the Q&A section, because I have a special offer for all of you that are attending, and it's only for people who attend the webinar. So stay tuned for that. All right, Brian.
All right, thank
Your
you.
turn.
All right, so we're going to do an overview of condition-based maintenance. Condition-based maintenance can mean a lot of things, and we'll talk about a handful of them here as we get our bearings before we have a little demo here and how it actually functions within a CMMS. So condition-based maintenance, right? Proactive maintenance strategies, real-time monitoring. We're determining the needs of the equipment's maintenance based on its condition, its actual condition, its context. What is it doing? What is it not doing? What is the wear? What is whatever, right? We're letting the machine dictate how we maintain it, right? And we use manual inspections. You can use sensors. You can use analytics. You can do all kinds of things in the pursuit of condition-based maintenance. All right. So it's a type of preventive maintenance, right? We're proactively looking at things. We're proactively performing work, right? Traditional PMs, right, are more fixed. Like we have time-based triggers, we have hours-based triggers, we have change-out schedules and things like that. Condition-based maintenance is geared more towards, is the machine in the window of failure? How do I know? And what am I going to do to address it and its needs, right? So it falls between preventive and predictive maintenance. So predictive maintenance, not a huge fan of the terms, but predictive maintenance is essentially we're leveraging real-time data to then make informed prescription of maintenance and what we should do in a timeline of failure, right? Okay, condition-based maintenance benefits. Of course, everyone knows we want to reduce downtime. We're not going to eliminate it, but we want to reduce it. We want to put downtime in the hands of us. We essentially want to dictate planned downtime based on condition of assets and how they should be functioning, right? Before a failure. There's Matthew Knuth, ambassador of Upkeep, great guy. He's a pro in here. He knows all about this. We want to improve efficiency, right? So we want to optimize our maintenance schedule. So if we know when things are in degradation, we can better plan them, right? Instead of something just failing and then now we have to react, we can now go and plan and schedule the work, know its condition and what needs to be done. And then extending asset life. Look, anything you do proactively from a maintenance standpoint is going to maintain the expected life of that asset. You're not going to increase it, but you're going to maintain its expected life. Oh, Amissa, we have a question here. It's tiny. Can we increase the size? It's full screen on my end. Let me see here. Display full screen. Is that better?
I think that's just from your view, Brian. That doesn't affect the audience.
Oh, really? Wow. Shows how much I know that stuff. Okay. Well,
I think it just depends on the person logging in, where they're what device they're using. So it'll probably look different to different people.
Okay, said it's better, so we'll roll with that.
Okay.
I want to be able to see something, you know what I mean?
Yeah.
Okay. Questions. How does your team currently decide when to perform preventive maintenance on equipment? There's no right or wrong answers. I say this all the time. People get so caught up with, am I doing the best practice? Am I this? Am I that? It's like, look, how is your business functioning? Are you performing maintenance within the guidelines and the alignment of the way the business operates, right? That could look bad to me, but good to you, right? So it's no right or wrong answer. How are we doing it? So Steven says the OEM determines this. Ooh, it's a slippery slope. We got to think about that. What else? Can you guys still hear me? Someone said I can't hear anything.
Yeah, I think you're good.
Okay.
Yeah, I got you.
Yeah, so for the audience, you guys, how does your team currently decide when to perform preventative maintenance?
I'm seeing a
couple answers.
I'm seeing a lot of manufacturer recommendations. They're a good starting point.
Meter-based.
Yeah.
Time-based.
Yep, time-based. Yeah, Garrett, you hit the nail on the head. That's right. OEM can provide the idea or the starting point, but it really depends on your environment, your context, your age, the skill sets. All of these things matter, right? Criticality assessment dictates PM frequency. Well, criticality is going to set up, where we should be putting our resources, but about the type of maintenance we do with that. Like, how are we doing that? You're right. OEM can be followed for warranty, but you can always do better than OEM standards. So OEM standards generally fall into one or two buckets based on my experience and many others. Either you're going to over maintain the machine in an effect to buy more spare parts, or you're going to under maintain the machine in order to get service contract and service works out of those manufacturers. So just keep that in mind. The PNF curve. Yeah, that's not really what we're asking here, but I understand. All right. Ready?
Yep, let's go.
All right. Using sensors for condition-based maintenance. All right. So what's the role of sensors, right? Sensors are real-time equipment health. They can monitor and proactive maintenance decisions. So a lot of times, and I've done this, and I still think it's very valuable to have operator-driven or technician-driven condition-based maintenance, meaning you're walking up to a machine, you're taking readings, you're taking pictures, you're doing no-go or no-go gauges, you're using edge detection for wear and things like that. I still find it extremely valuable. Here's the caveat. Sensors don't need to eat. They don't need to sleep, and you can put them anywhere. They don't have to follow PPE guidelines. They don't have to follow restricted areas. They can go in an area that has no oxygen, right? So sensors allow you to expand the human footprint in our pursuit of understanding condition of machines. I hope that makes sense. Okay, for vibration, use cases. So we have bearing monitoring, right? We can look at defects, misalignment, lubrication issues. We have imbalances for shafts and rotors, gearbox health. We can see if teeth are cracked or worn or broken, right? We can also see if lubrication is an issue between those meshing gears, right? We have cavitation. Cavitation creates essentially microscopic explosions, right? That can have impeller damage and all types of other pieces of hydraulic and pumps and things like that. And then structural monitoring, right? You can use a vibration sensor to understand the resonance in certain structures, right? Matthew Knuth in this chat right now can tell you that he can pick up loose bolts and vibrating mounts, right, with sensor technology, and the motor and the sensors mounted on the motor. So there's all different types of things you can do there with vibration. Vibration is huge. It's $1 billion market. Temperature. This is a big one. Temperature is the more broad sensor technology that we see and that we actually, I would say, John, correct me if I'm wrong, we probably have more temperature sensors out there than anything, huh?
Yeah, I agree.
I mean, there's just so many opportunities for thermal evaluation, right? We have bearings and motors that have thermal expansion and thermal loads. Lubrication, of course, right? Electrical systems, you have increases in current and you have high resistive values in circuits and things like that. You're going to see a thermal property there. Heat exchangers, boilers, of course, pumps, compressors, same thing, right? Temperature sensors are huge. We sell them and we have them in so many facilities across the United States and the world, particularly in food and beverage and monitoring HVAC systems and climate control and all types of stuff. Pressure sensors, same thing, right? They're all going to be relatively in the same alignment, just depending on what you're looking for. Pumps, compressors, of course, hydraulic systems, of course, boilers, pneumatics, filters. So filters, right, we use differential pressure sensors so we can measure upstream and downstream pressures and know if there's some sort of blockage between media. Hydraulic systems, I mean, everything is running off of a flow, and the restriction to that flow creates a pressure. We want to monitor that pressure. We can also monitor flow too, if that makes it better for you. Current, again, right? Current is great for on-off monitoring if you want to measure the cycle and run times of electrical components and machinery. You can detect faults, right? If we have overload faults on machines, or we have trip outs on motors or compressors or anything like that. Electrical loads are monitored everywhere, and extremely, extremely valuable. A good one here, and talking about sustainable type things, is batteries. Battery banks have become very, very, very popular, and using current, which we call CTs, current transformers, is very valuable in monitoring your amp hours, your draw, if you have parasitic loads on those battery banks, and all types of stuff. So very, very good. What's the range of current monitoring? There's all different types. If you want more information on that, Mark, please reach out and we can get you set up with that information. Okay. Question. Have you used sensors to monitor equipment health? It could be any sensor. It could be vibration. It can be flow. It can be current. It can be pressure. It can be anything you want. RPM. Maybe it's switch power on and off. What do you got? So James uses sensors. Ricardo uses temperatures. Yep, he's got 4 online right now. A lot of typing going on.
Seems like it's a very sensitive question.
Temperature, yep. Temperature is a big one. I mean, there's just so many things that can be derived from temperature, right? Anytime you have mechanical movement, it's likely that you're going to generate a heat signature. We got Matthew with vibration, temp, fluid, flow, pressure. Well, he's got everything. Vibration sensors, and we have humidity sensors from Upkeep right now. That's great. Hope Daniel's providing some troubleshooting for our listeners here. That's very nice.
Technical assistance from Daniel. Thank you, Daniel.
Matthew Canute, you're right. Temperature is the last line of defense. That's right. If we're making heat, we already got a failure.
Brian, did you miss John's pun? He said it's a sensitive subject.
I definitely did. I was reading these. So Matthew Knuth makes a good point, right? If we look at the PNF interval, temperature is telling us we're well into the failure line. We're right on the failure curve, right? So lubrication analysis is very, very towards the top. Same with ultrasound and vibration. All right, moving on. Okay, implementation of sensors. So most of the time, 90% of the time, you're going to be monitoring critical assets, things that matter to the business, things that are going to have compounding production stoppage. Not just a machine stopping from producing, but a machine that when it stops, maybe it creates a ton of idle manpower or labor, right? Or you have missed opportunities because these things are not getting out the door. So we're going to monitor critical things first. We want to minimize the impact to our production that makes us our money, right? Or that, other things are safety, right? If there's a highly critical machine that is can affect your environmental health or safety conditions, we want to monitor that thing. And then also we have compliance too. Some of you are in worlds that are compliant. An example is food and beverage. Some of the storage for your produce has to be below a certain temperature at all times. So we monitor those spaces to make sure that is the case. And we actually capture it because when we go through SQF audits or GMP violations, all kinds of stuff that have to be taken care of. And we have to have that data to say we've been doing the right thing. And this can help. All right, selecting your sensors. We want to be looking at what do we want, right? So we've identified what machines are important to us. Now, what do we want to be looking at? What do we want to monitor on these machines? We use the term failure modes here because we're making the assumption that we understand where things are failing, whether we're having bolts break or we're losing belts or we're having temperature spikes or we're having humidity spikes or we're having a loss of head pressure from a pump, right? So we have to know these failure modes so that we can identify a sensor that's going to help remedy or at least give us an idea of when these failure modes are likely to occur so that we can take action. It can be anything. We've talked about a ton here, and they're all available. All right, connecting to your centralized data management system or your CMMS, right? Upkeep is a CMMS company. There's no surprise. We do this. We have the integrations. John on this call, I know he's been very quiet, but he's not going to be in a little bit. He is our expert in CMMS, in upkeep. No one knows upkeep better than John does. And he's going to drive that home for sure. But you got to have a way for these sensors to give you the information in a structured way. And it has to be consumable, digestible, and ultimately provide value for you. That's where your CMMS comes in. But there are other companies that are not a CMMS that can do a lot of that information for you as well. It's just a little different. All right. This is a huge one, and it's often overlooked, which is you have to know a baseline condition. You have to know essentially what good looks like. You're not going to know when an anomaly or a threshold of an anomaly is occurring if you don't even know what good looks like. If I have I'm making stuff up, if I have a filter that I want to monitor the differential pressure, right? And I want to make sure that it's always below 2 psi, meaning the accumulation of debris in this filter does not restrict the flow of air by 2 psi. So I would want to make sure that the sensor's threshold is like 1.5 psi. So that I know, bang, 1.5 psi. Okay, I've got half a psi left. That gives me this amount of time to change that filter, right? We have to know the baseline conditions. We can't just go, oh, it works, cool, and we don't know where we're at. Super important. That's why I'm talking about it a lot. Set up regular data reviews. So just like anything, you can't just set and forget these things. You have to constantly benchmark them against past readings, right? So if you're seeing odd things, don't just automatically assume that you have some bearing that's flying apart out on the production line. You have to investigate. You know, I like to use the example of auto lubrication systems. If any of you are familiar with them, I come from mining. They're extremely popular. We had implemented PLC controlled automatic lubrication systems. And people were like, oh, we'll implement these and then we never have to worry about it again. And I go, wrong. We're going to implement these and then we're going to set up a strategy to monitor them. It won't be as much and it won't be as involved, but we still have to pay attention to these things. We have to refine thresholds. We have to understand the context, and we have to constantly be ensuring that these sensors that we're relying on are actually accurate. He says, I loathe their existence at times. I like them. Becca Max is the best, in my opinion. Don't argue with me. All right. Benefits of using sensors for condition-based maintenance. All right. We want to mitigate failures. That is the name of the game, right? Failure in industry is $1 trillion business. We love service providers. We love failure. If you've got a group of contractors that you have on speed dial, they love when your stuff is not running right. It makes the money. Trust me, I know from experience. So we want to mitigate it. We want to track the machine's run times, the cycle counts, the production volume. We want to drive all of these from our maintenance perspective. We want to be on top of it. We want to be setting these thresholds and getting to performing maintenance or doing change outs or replacing parts or whatever before a failure happens, and preferably right before a failure happens, because then your cost effectiveness with your maintenance has been achieved, meaning you've let that part or that whatever see its maximum useful life, and then bam, you replace it with a new one. And then you do the same thing over and over again. We don't want to be replacing too soon, and we certainly don't want to be replacing too late. That's a cost-effective maintenance in mitigating failures. All right, downtime. Failures and downtime are not always proportional, and anybody who's been in manufacturing will understand that, because they'll also know that the operator, when they do their checklist, will say, I had to restart this thing 12 times. Well, it didn't, there was no fire, right? On the flip side, a belt could break in half and send all your product on the ground. No, that's a failure too, right? So downtime and failure are not always proportional, but downtime is the time in which it takes to restore it, right? That's the money loss time. So we want to know what assets went down, how long were they down, and why. How long is what everyone's going to ask first. You all know that from experience. The next is going to be, how much is it going to cost? And the third is, why was it down? And then a lot of times, a lot of nonsense comes from downtime where some executive will go, when's the last time you did your PMs? We got to do more PMs. We got to do more PMs. Hate to break it to you, executive. PMs don't stop failures. They mitigate them. Failures are always going to happen. We just want to be ahead of them, right? But with sensors, particularly in upkeep, we know which assets they are. We will know the time, the downtime. We have that just in the CMMS function as well. And then why. We can use work order types. We can use failure codes. And then also the sensors themselves will put out certain data that you can use to leverage for understanding why things have gone down. Track and understand. I basically went into that from last time, right? We can understand it. We can understand these failure codes, sensors, check conditions, all these things are doable. Some more in-depth than others. But if you know your thresholds, if you know what good looks like, and the sensor or the technology is able to provide you what good looks like and what bad looks like, it's likely that you're going to be ahead in some manner, right? Okay. So we know we talk about OEE and whatever, right? Overall equipment effectiveness. It drives the bottom line. OEE is like a standard of I'm using manufacturing as the example, right? We want to maximize availability and utilization. If machines are running and we're able to monitor their condition without touching them, it's likely they're going to be highly available and they're going to be highly utilized. If we're constantly taking machines out of their operating context to fool with them, it's likely that we're not going to have high availability and high utilization. Availability and utilization are proportional, right? If a machine is available, it's likely it's going to be utilized. If it's not available, it's not going to be utilized. So keep that in mind. It's important, right? Maintenance inherently is intrusive. And if we're leveraging condition-based maintenance, we can create strategies that are non-intrusive so that machines can operate and we understand where they are in their life cycle or their context. And then we make decisions based on that instead of stopping the thing, tearing it apart, going, oh my God, this bearing's wearing. You get what I'm saying? I said it, utilization, super important. Machines operate, you utilize them, you can turn out. And we monitor that utilization, right? Whether it's runtime hours or whatever. So what would happen in my past is we would be running large mining trucks and we'd have a certain amount of tons in those mining trucks. And we would understand the cost per ton and the cost per ton per hour. Well, because I was leveraging telematics and sensors, I knew how long those machines were operating in a shift, the tonnage they were hauling, and we were able to give them those numbers that they could then do their analysis on and understand the cost per ton, the cost per ton per hour, the handling costs, all those things. Same things can be done with conveyors and other things as well. Benefits. Self-explanatory, right? We get accurate information as long as we are maintaining our condition-based maintenance, our condition-based sensors, right? We can scale better. That means we essentially need less resources to monitor the same amount of things, assuming we've done our homework. We'll know the context of assets that need more attention. We call them bad actors. You guys know that term. We can understand whys better. Whys allow us to then implement defect elimination. A lot of you also know what that is. It's like the end all be all of preventive maintenance, right? Is eliminating preventive maintenance altogether. Find the defect, get rid of it, take that task off the check sheet and move on. Reducing downtime and of course, cost-effective maintenance. You will hear me talk about that a lot. Doing maintenance that's proportional to the value and the operational characteristics of a machine. Considerations. Cost. It's expensive up front, but there are ways to make that argument, particularly if it comes down to EHS, environmental health and safety. That's probably the easiest one. Or if you have super high production capacity on certain machines and you're currently taking them down in scheduled times to look at, and operations knows that they could get that time back if they put a sensor on it, they're going to agree with you. Make relationships with operations and safety professionals as to why these things are valuable, because then you have a bunch of people speaking on your behalf. Cybersecurity risks. I don't know a lot about this subject, but I'm sure there's people that are smart enough to hack into a sensor that's connected to a LAN or a network or something, and that, right? So think about that as well. And then this is the biggest one, technical expertise. If you don't know anything about vibration sensors and you want to put vibration sensors all over your stuff, you better call somebody like Matt Knuth, because you need to have expertise in these environments. As great as it is, you can't just plug and play. You wouldn't believe we find sensors installed wrong. We find things hooked up incorrectly. We have the wrong RPM data. I mean, there's just so much that happens when we're confiding in that sensor to tell us something and it's set up wrong. You need to consult experts in this field. And there may be experts in different fields pertaining to the technology you're using. If you're using motion amplification, you need to talk to those people. If you're talking to vibration, talk to those people, and so on and so on. That's a super important one. It is last on this list, but it is the most important one, hands down. All right. I'm going to hand it over to my friend, John Sapko.
All right, sounds good. While I'm waiting to share my screen, y'all, just a quick PSA. I have a lot of technology issues today on my end. So before technology started going wrong, I created a recording of this just in case. So we always do that when we do these webinars. We create backups of backups. So today, thankfully, I have a backup to show us. So this is going to be the recording I have this morning. So if you don't see me speak, I'm still here. This is just me 6 hours earlier. Let me know if y'all can't hear it. Screen. Right now, what you're seeing is my phone on the right-hand side. This is our mobile application. This is where we create work orders, execute work orders, create requests, perform asset management without having to go to a desktop. We are a mobile-first company, so I always want to make sure that everyone knows that whenever you utilize Upkeep, utilize the application. It is extremely easy to use. It's extremely powerful. There's a lot you can do with that. Today's focus is on condition-based maintenance. So we'll come back to the app here in a second. And I really want to get into condition-based monitoring and maintenance. And so what you're looking here now is the web-based platform. You can access the same page on your mobile device. It's optimized for a mobile screen as well. And what you're seeing are some sensors that I have linked to my demo account. And I actually use this to monitor something very real in my life that I'm going to give you an example later on. But I want to show everyone right off the bat how we can actually create work orders and monitor data very quickly right now, and then we'll kind of backtrack into things. So you're seeing these, what you're seeing right now are sensors. So all of these different squares are a representation of a sensor. So we have temperature, current, water detection or the presence of water, a humidity sensor, and another temperature sensor. We do also offer vibration sensors. So temperature, current, vibration, humidity, and the presence of water. Once you get those sensors, they're wireless, like we spoke earlier. They hook into your gateway, which transmits either over your own network or over cellular signal. And all you have to do is add the device into Upkeep by giving that device ID. There's a little code on it, and you select where these things are in your facility. You select what asset they're attached to, and then you can even have it sync to meters within Upkeep. We'll talk about that a little bit. So when we talk about meters and things like that, they're different than sensors. So meters, pretty much every CMMS that calls itself real CMMS has a meter functionality to it, meaning you can set up consumption points to enter data into. So that could be runtime hours, it could be cycle counts, it could be temperature, vibration, current, whatever metric you guys are trying to, or whatever that company that we're talking about is trying to track. That is manual condition-based maintenance, right? So we're talking about automating that right now with sensors that Upkeep provides. And the sensors are already integrated into Upkeep. So when we say, sync to a meter within Upkeep, it's exactly what we're talking about. So if I come here to my my meters page in Upkeep, we've now moved from edge to meters, and we are looking at meters that are synced to sensors. So we're not only collecting data on the meter, on the sensor itself, we are also sending it automatically to meters in Upkeep. Why does any of that matter? It matters because now you no longer have to take these readings manually. They are coming to Upkeep automatically. You don't have to create rounds. You don't have to create work orders to do all this stuff. It's happening in real time, and you're collecting these readings in real time, and you're able to trigger corrective action from them if needed. So we're actually going to do that right now. We're actually going to trip a sensor. We're going to come to our work order queue here. We are moving We are improving our work orders here very soon, so I'm going to toggle on this this beta here. And what you're going to see is right now we don't have any work orders that say anything along the lines of leak or sensor trip. But what we're going to see here, as soon as I upset one of these sensors, we're going to see a new work order created by Upkeep. So let's come back to our sensor page here real fast, and we're going to focus in on this sensor on the right-hand side where my mouse is hovering. And I'm also going to bring it over my phone again, and I'm going to turn on the camera part. And you're going to see here that we have a sensor on my desk. This is the water sensor, and I've got a little tub of water there. We're going to dunk that in there real quick. Bring it back out. And let me actually just dry everything off here real quick. And then when we hit refresh here on the screen, we're going to see that this sensor is now unhappy with what we just did because it is now detecting the presence of water. And what we should have is a work order that's created in Upkeep. So we'll go ahead and refresh this screen. And you can see now that we have a work order created in Upkeep. So this work order was created by a sensor reading, and it has title, description, a location, an asset tied to it, and it's automatically assigned to a primary assignee and a team. And if we come back to our mobile application, we're going to see that we can actually see that work order in our mobile app as well. All this was done within seconds of that sensor tripping. So as a technician, I can now look at all this stuff and look at how amazing this is. We have almost a full maintenance plan ready to go for us. We know where we're going, the asset that we're going to, the tasks that are involved, and we have a plan ready to go. Now, obviously, we can plan even further by doing some estimated time and all that good stuff there, and what parts we need. But this is an example of how we can actually perform condition-based maintenance based on the readings that we're getting from our sensors. Okay, so I wanted to show that real quickly because now I want to talk about how we do that. So when we connect our sensors, we're not only going to be able to visualize them and filter and sort by them like I'm doing now, we're going to be able to set up alerts and parameters about them. But what do we need first? We need data first. So when we look at these sensors here, we can actually look at all of this data that we have in the sensors themselves. And we can start measuring and seeing everything about them. So some folks might know if they're trying to detect average current or max current, what the parameters would be, and some folks might not know. But when you start aggregating and collecting data, you're going to be able to correlate failures and work orders with the data that you're receiving so that you can come back into Upkeep, come to alerts, and configure them and say, okay, now I know when we go above a certain amp level or below a certain amp level, that actually means we have a problem and I need to be alerted about it. So how do we create those alerts? We do that, and I'll just click on some that I have here. We do that in this alert section here. And what this is going to provide us the ability to do is select our device, give it a name, and then it's already got a name, but we're going to set the alert name so we can track it. And then we're also going to define what we want to measure. So in my humidity sensor, I want to say, hey, if the humidity is greater than or goes below than a certain point, then send me an alert. And if the dew point, actually I need to edit this right now, so let's go ahead and do that. If the dew point falls below a certain point, meaning 63% or 50%, and it holds for 10 minutes, send me an alert. But I can actually hold this for 15 minutes. Or maybe I want to say, no. Only if it goes 1 minute, then I need to be alerted. I'm actually going to change this right now and set it for 15 minutes. This email address is actually incorrect, so I need to update that as well. If you all want to email me, there's my email address. Please don't spam me. And then we're going to then save that. And now we have everything adjusted. So I'm monitoring humidity and dew point. And what this is going to give me is the alerts, and if it holds for this amount of time, and it's going to send me emails and text messages. Now I can add as many phone numbers as I want, as many emails as I want to this, and it's going to I'm going to know when this is an alert. Now, this is not a work order, right? We're just being alerted that, hey, your sensor is out of range, just like it's indicating here on the excuse me, on the water sensor. And then also, because I made that adjustment on the cool storage sensor, you're now seeing that it is also out of adjustment here. So it's the dew point is actually really low. So maybe I need to adjust that. Maybe that's not normal. So I said that I have a real life example to give you. This cool storage sensor here, the humidity sensor, is actually located in my crawl space. So if we go back to, if we go into this sensor, and I actually want to go back to the beginning of 2023. And we'll focus in on this range. This is when I had my crawl space remediated, and I also had a encapsulation done and a dehumidifier installed into my crawl space. We had a ton of mold. It was disgusting. My family was getting sick, and we just bought the house too. So kind of a bummer to get into. And then all of a sudden we had mold, 6 months into the house. So anyway, I guess that's first time home buyer problems. So in the beginning of January, we have our remediation done, and me wanting to make sure that we never have a problem again, I threw this humidity sensor in there, and I started taking readings. Now I wasn't monitoring it; I was just kind of throwing it in there for demo purposes, to be honest, just to get some data, some real life data, so I can actually kind of show this system like I am today. And around from January to the beginning of March, or actually tail end of March, around here, I had a conversation with my wife one morning, and I said, hey, have you heard the dehumidifier go on and off? It's kind of like your fridge where you don't know it's on, but if you hear it turn off, you're like, oh, there's the dehumidifier. And she said, no, I haven't heard it in a while. And I was like, huh, that's interesting. And so I checked the sensor on upkeep, and all of a sudden it doesn't look too bad, but I'm like, shouldn't it be way less than 60 to 70, 60%? I didn't know. They didn't tell me. So I do a little research, and come to find out the sweet spot should be like 60, like right here, like 63, 64%, and never going below 50% humidity. So where these two lines are is where we should be. How are we getting these two reference lines here? So that's coming from the alerts. That's what's telling me this is where we want to be. So I call up my contractor and I say, hey, we are now at way above 70%. I think the dehumidifier is broken, or there's something wrong with the encapsulation that you all did. Can you please come take a look at this? They said yes. They come, they inspect it, everything is fine. They do measurements. They said, look, we reset the dehumidifier. It's going to take it a bit to come back to normal range, so give it a week. A week happens and still the same. They come back out. They say the humidifier is fine, or dehumidifier is fine, and they reset it, and it shows signs of life. As you can see, it starts to work here, but then kind of flatlines. So I did not show them any of this. So we go through 3 or 4 times of going back and forth. They're sending their technicians out, and they finally say, hey, John, we got to start charging you. We're coming out here way too often, and there's nothing wrong with the dehumidifier. And I say, okay, well, let me show you what I'm seeing here. I have a sensor, and here's all the history. And let me actually bring this up right now and zoom in on it. I have been dealing with this since beginning of March, and we are now well into May, and we still have not resolved this issue, y'all. They take a look at this, and they say, hey, can you actually send us a screenshot of this? So I send them a screenshot. The next day, they come back with a brand new dehumidifier. They were able to provide this with their company that they get the dehumidifier from, validate that it is a warranty issue because of this data, and I was able to get my dehumidifier replaced. They installed it. Around this, it kind of had a few days of calibrating, and then bam, it's now looking like this moving forward. So the moral of the story is, this is how I was able to use our sensors to actually get things done on my end and correct issues. So what we've just talked about was connecting your sensors, monitoring them in real time, being able to look at your sensor and their data, being able to collect readings like I am now, zoom in on those readings, set parameters of those readings, and take corrective action when necessary. But let's say that you don't have these linked to your meters. Maybe you just want to get alerts, but you still want to take action on those alerts. Can you create work orders from those alerts? Yes, you can. So if we come into this alert section here, and I want to look at some incidents in the last week or so, I can see here we have an incident that was resolved, but if it wasn't resolved, I could actually create a work order or a request from here to drive that process without even going through the meters. If you're asking yourself, well, how does this get resolved? It gets resolved by the temperature or the sensor coming back into normal range based on the configuration of your alert. So that's what tells the sensor that we're back into normal range. Before I pass it back to Brian and Amissa here, we also have on our current sensors the concept of runtime. So what this runtime is going to allow you all to do is set actual operating schedules of when we should be seeing readings come into place directly to your asset. And it's going to start calculating the runtime based on the schedule that we have here. And then we can even tell it to say, hey, if the meter is synced, we want it to always be synced to this runtime here. And then we also could say something like this. If it goes above a certain threshold, we can actually trigger the asset status to be available, off production, not available, or just blanket not available. So what this is referring to here is the asset status in Upkeep. So for those of you who don't know, I'm going to jump over to our assets page here. I'm going to move over the status. You are able to tell the status of an asset at any point in time, whether you're on the mobile app or you're on the web app. This is also how we track downtime too. And so if we're connected to our sensors and if we have runtime sensors here and it falls below a certain threshold or reaches this threshold, I should say, then we can actually trigger the status to go and start collecting downtime based on this threshold. All right, they only gave me about 15 minutes to run this demo. I'm already over time, but if you all have any questions, feel free to send them in. We'll get those questions answered to you if we can't get them answered here.
Cool. Thanks, John.
Oh. Yeah, my pleasure, y'all.
All right, let me get back here. Hold on a sec.
All right.
Can you guys see the screen still okay?
Can't see. It doesn't look like you're sharing your screen.
Really?
Few more minutes, guys, and we will be wrapping this up. We still have a couple more things to touch on before we conclude the webinar.
All right. Can you guys see my screen?
Nope.
Really? It says it's still sharing. What is going on here?
Oh, okay, yeah. There you go.
You're
Okay.
good.
Sorry.
All right. That was that. Okay. So this is kind of just a recap that we talked about, right? And this is, integrating the sensors within Upkeep. Of course, we identify critical assets. We talked about that. We select the appropriate sensor, connect the sensors to Upkeep so we can integrate them with data collection. I mean, John knows more about this than I do, but we integrate with PLCs. We integrate through our own network and all types of things. So we set up our data collection, our alerts. That's our baselining. That's the thresholds that John has gone over and shown. We want to set up what good looks like, what we don't want to see, right? Which is our thresholds and our top of our edge, or what we call like an edge detection, right? Which is we're creeping up on a problem. And then we leverage that data, where there's no point in collecting data to just see when something breaks, right? It should be leveraged to optimize your maintenance strategy. You still got to go turn the wrenches. You still have to use your meter. You still have to do those things. This is not a silver bullet. It's not going to solve your problems. It's going to provide insight, and it's going to allow you to optimize your existing problem or your existing processes. Sorry, not your existing problems. So yeah, we got to make sure we're doing the right things before we get sensors, while we have sensors, and even after we're leveraging them for a while. All right, Amissa.
Yeah, okay. I'm going to speed through this just because I really want to make sure we have at least a few minutes for questions at the end, because there's a couple good ones in there already. If you guys have questions, type them into the question feature right now so that we can make sure we address them. So these are just a couple examples of some of our customers that have started using sensors for condition-based maintenance. So Primal Pet Foods, they were downtime was like a major problem for them. So anytime a production line went down, it would cost them $160,000 a day. That's a lot. I mean, some companies can lose more, some companies lose less, but that is a lot per day to be losing for a company's bottom line. So because they were doing reactive maintenance and they didn't have any real-time visibility, they couldn't really prevent breakdowns. And so that was a big challenge for them. They started looking into CMMSs and sensors. They decided to go with Upkeep, and they started monitoring their asset health in real time. So they were tracking temperature, vibration, and other key indicators that they needed to track, and they were able to start catching failures before they happened. So now their sensor data detects issues. They use Upkeep to automatically create the work order, and then the maintenance team acts before the breakdown occurs. So this shift has led to fewer failures and reduced downtime and a more efficient operation for them. Next customer example is Icon Entertainment. They're actually restaurants and amusement parks, but they have like one of their high-end restaurants, and they were using they're using sensors for condition-based maintenance, especially when it comes to food spoilage. So they had a history of having some of the refrigerators fail, and they were losing, like one time they lost like $8,000 in product because of that. So they were like, okay, we really need to get a CMMS. We need to start using sensors for this. So they went with Upkeep. They installed some sensors, and they started tracking their temperature fluctuations in real time. So instead of waiting for the refrigerator to fail and losing product, their team now gets instant automated alerts anytime the cooler starts to drift outside of what they have determined as their safe conditions. So since they started doing this, they have prevented spoilage again, reduced emergency maintenance, which I think is really important to note, that they don't have to come in due to an emergency. They can prevent it ahead of time. And now they have full visibility into their critical equipment. And so they have saved thousands of dollars by doing this. So it has paid for itself for sure for them. Okay, so before we start reading off the questions, I have, if you guys saw in the chat, I was posting a little offer that we have for you guys. If you're interested in learning more about sensors, seeing how that would work within a CMMS, if you go to the link I put in the chat, if you fill out and request and schedule a demo, email me, let me know you've done that, and then I'm going to send you a special gift. I think you guys will actually really like the gift that I'm going to send you. So do that and then email me, and then I will send you that gift. All right, let's look at these questions. Okay. This is a good question because I don't actually know the answer to this. Can the sensor be mounted on a mobile machine? If so, when disconnected from power for storage until needed, would that affect readings and data?
All right, so I'm gonna let John answer that question. I don't know what you're talking about as far as a mobile machine. If you're talking about mobile equipment, the answer is no. There are better solutions, and if you're interested in that, you can email us. But John, what do you think?
Yeah, I mean, so the sensors, they communicate to a gateway that has about 1,000-foot range horizontal and about a 500 to 800-foot vertical range. So if you want to mount that wireless sensor to a mobile device that stays within 1,000 feet, then theoretically, yes, but I wouldn't recommend it.
Okay, thank you. And then Daniel was also wondering, And I can always send him some examples too and take this offline. But he was wondering if you can provide some examples on how the sensors can be used in food and beverage manufacturing.
Sure.
Yeah. What do you got on that?
Okay, so one example, and I think Daniel works at a bakery, if I'm correct. Your ovens. So you have giant ovens that I'm assuming your products go through and get cooked, and you have rising boxes and all these things, right? I also know that those ovens have a tremendous amount of current draw. You could leverage CTs, current transformers, or current monitoring to understand the loads of those ovens in proportion to how much product you're putting through. You could also monitor your conveyance for runtime so that you can maximize changeouts in your conveyor belt components, your gears, your gearboxes, your motors. If you have any very critical, I worked with a guy who, when I was the head of a food and beverage manufacturer, my planner was from a bakery, and he'd always talk about these dough mixing machines and how super critical they were and how heavy all the dough was. So if you have things like that, you can monitor vibration on those large gearboxes and motors. I mean, there's a ton. Temperature is obvious, right? But current for your ovens and your proving boxes and all that stuff. And then, of course, any type of temperature or vibration for any of your other critical equipment.
Thanks, Brian. Yeah, and maybe we can answer this question here. If not, I will email you. But do you guys know offhand, are there any colleges and universities that utilize this technology in the DC metro area?
Okay, so
if you don't know the answer, then maybe you can talk about how universities and colleges utilize sensors.
So I don't know if it's college and universities, but I do know Carter Caterpillar, which is the Caterpillar dealer in Maryland, DC, and Virginia. They are leveraging our sensors in their facilities. So that is in that area. Colleges, I'm not sure. I don't know, but I know we do. John can correct me. I think we do have colleges that are leveraging HVAC monitoring, fire water, and some other things. Yeah.
Yeah, I mean, we absolutely do. It just depends on whether or not they're okay with us sharing their name or not.
Yeah. I name dropped. I used to work there, so it's fine.
Okay. I was going to say, I don't know if you're supposed to say that, Brian.
Fine.
Okay. You guys didn't hear that. All right. Ahmed has a question. He says, I do not understand how sensor readings are registered to the CMMS. I know that SCADA can monitor and control while CMMS manage work orders and spare parts, purchasing, and so on. But what are you talking about, if I understand? Basically trying to understand how is that happening between the sensors and the CMMS?
So the sensors are connected to a gateway, right? The gateway is connected to the internet. Am I correct, John? The internet's connected to the CMMS, and they're paired together, right, through an API. SCADA system is your building automation system, right? The sensors can also be integrated into that SCADA system as well, if you're running PLCs and things like that. So I think you're confusing two things. The CMMS is your work management. We're talking about condition-based maintenance, to where sensors and those types of things are providing data to the CMMS so that when things are an anomaly, we can generate a corrective work order, assign it to somebody, and it can be prioritized immediately, as opposed to just having something fail and you walk up on it and then, I need to create a corrective work order. The same thing can be done with your SCADA system. John, correct me if I'm wrong. I'm pretty sure we talk to SCADA systems as well, and our sensors can go through SCADA systems.
Yeah, I mean, you're absolutely correct. So you actually can have both at the same time. So one of our customers that I cannot name, we are integrated into their SCADA system, and they're using our edge sensors. And so how that works is everything that their SCADA system is actually sending us all the meter data. So we have thousands of meters that their SCADA system is sending us data into. Then from the edge sensor standpoint, they're using our sensors to supplement where they don't have any PLCs or any other SCADA system. So they're basically patching all the holes that their SCADA system cannot fill with our sensors. And so that is also sending data to meter, and they're triggering work orders based on both readings at the same time.
Okay. All right. Well, we are at time, everybody. So we really appreciate you attending this webinar, sticking into the end with us. Again, the links to get the special gift is in the chat. And then please, like if you need a recording and you didn't get it, or you need a copy of the deck, or you have questions about whatever we have talked about on this webinar, you can email me personally and I'll make sure you get connected to the resources that you need. Otherwise, thank you, everybody.
Thanks, everybody.
Thanks, y'all.
Bye. Have a good day.